Hi dear students, today we will discuss about the Arndt-Einstert reaction. The main objectives of this Arndt-Einstert reaction is to understand the mechanism of the reaction and its applications in organic synthesis. And next one is to identify the types of compounds which are involved in the Arndt-Einstert reaction. And next one is to explain the role of diazomethane in this reaction. And last one is to predict the possible products of the Arndt-Einstert reaction given in specific starting materials. Then what is the definition of Arndt-Einstert reaction? So Arndt-Einstert reaction is nothing but the conversion of carboxylic acid to one carbon homologated carboxylic acid, which is nothing but chain lengthened to one carbon via alpha diazoketone and subsequently Wolff rearrangement of the intermediate in the presence of water and silver oxide used as a catalyst or thermal conditions or in the case of photochemical conditions. Then the reaction was named after the German scientist Fritz Arndt and Bernd Einstert. So Arndt-Einstert reaction is the general conversion of alpha diazoketone to higher homologues of acid or acid derivatives via the ketene intermediate is known as Wolff rearrangement. Then if we see the reaction of Arndt-Einstert reaction, first of all this carboxylic acid which on reaction with thionyl chloride or phosphorus pentachloride which leads to the formation of acid chlorides. These acid chlorides on reaction with diazomethane which leads to the formation of alpha diazoketones. These alpha diazoketones on reaction with catalyst silver oxide which leads to the formation of the intermediate, that is ketene will forms. So these ketene on reaction with water which leads to the formation of homologated carboxylic acid. So instead of water, if we take ammonia, then we get amides. Then if we use alcohols, then we get esters, and then if we use amines, then we can get the substituted amides. Then the pathway or the mechanism of the reaction. So the mechanism of this Arndt-Einstert reaction undergoes with 7 steps. So in first step, that is a nucleophilic attack by the diazomethane into carbonyl carbon atom of acetyl chloride which forms a diazoketone. This is the first step. In case of second step, elimination of chloride and formation of diazoketone will take place. Then in case of step 3, abstraction of proton from the diazomethane. Then step 4, migration of alkyl group and formation of ketene intermediate will take place. In the case of step 5, nucleophilic attack by water to the ketone. And next step is proton transfer, and the last step is tautomerization, which gives the desired products. Then if you see the total mechanism of the Arndt-Einstert reaction. So first of all, if we see acetyl chloride, this acetyl chloride on reaction with diazomethane, that is the step 1, which is a nucleophilic attack by diazomethane to carbonyl carbon of acetyl chloride, which leads to the formation of 4 carbon intermediate will takes place. 4 carbon intermediate will takes place. So this 4 carbon intermediate, by the removal of chloride, then which leads to the formation of, so diazoketone will takes place. Diazoketone. So this diazoketone, further the abstraction of proton by diazomethane will takes place, which leads to the formation of subsequently the migration of alkyl group from carbonyl carbon to, so this carbon will takes place. Then that will leads to the formation of ketene intermediate will takes place. This is the ketene intermediate. This ketene intermediate is a unstable species and a short-lived species. That means, so this ketene rapidly further reaction with water molecule, then that will leads to the formation of this product, but this is a oxygen having positive charge is highly unstable, then so proton transfer will takes place. Proton transfer will takes place from, so oxygen to this oxygen will takes place. Then next step, in this step, so that carbon is less electronegative, then which is attached with 2 more electronegative oxygen atoms, but this is highly unstable. That's why, so the proton transfer will takes place. That means, so tautomerization will takes place. Tautomerization will takes place, that will leads to the formation of this homologated carboxylic acid will takes place. So in this product, 1 carbon is homologated. The chain length is increased by 1 carbon. So this is the mechanism of the Arndt-Einstert synthesis. Then next, in the presence of other reagents such as alcohols or amines or ammonia, instead of water, corresponding acid derivatives of higher homologous are formed. That means, so esters, amides, substituted amides and amines will be obtained. So if we see the reaction, this is the ketene intermediate. So this is the ketene intermediate. This ketene intermediates on further reaction with alcohol, that means in case of water, which leads to the formation of homologated carboxylic acid. But in case of, so if we take ammonia as the reagent, in case that which leads to the formation of amides as the product. But if we take amines as the reagents, then we get the substituted amides. Then further, if we take the reagent as alcohol, then we get the esters as the products. So instead of water, if we use another reagent, then we can get the different corresponding homologated products are formed. Then in case of, so in the absence of silver oxide catalyst, the simple addition of water to the diazoketone occurs in the presence of formic acid and hydroxymethyl ketone is formed, which is nothing but substituted nucleophilic reaction. Then if we see the reaction, then this diazoketone on reaction with water, so followed by the formic acid without catalyst, which leads to the formation of hydroxy methyl ketone as the product. Then, so in case of this important synthetic applications of Arndt-Einstert synthesis is, so this Arndt-Einstert synthesis of acids has an important advantage over other methods, which is that this method does not require any reduction, and hence it is extremely useful for the compounds so containing reducible groups like so nitro groups, cyano groups, keto groups, and lactones or esters. So this is the one of the important synthetic applications of Arndt-Einstert reaction. Then the example for this synthetic applications, if we see conversion of orthonitro-benzoic acid into orthonitro-phenylacetic acid. The nitro group in this orthonitro-benzoic acid is not reduced, only this group will be homologated. So if we see this, this is the orthonitro-benzoic acid, orthonitro-benzoic acid, and this group is a so reducible group. This on reaction with thionyl chloride followed by the diazomethane, so then that which leads to the formation of, followed by the water, reaction with water, then homologated carboxylic acid will take place, but the NO2 group is not reducible in any case. This is very important synthetic application in case of Arndt-Einstert reaction. And also there are another synthetic application in case of Arndt-Einstert reaction is it is also used for the synthesis of various natural products like estrone and corticoids. Another important application is, so this Arndt-Einstert reaction is used for the synthesis of papaverine. So in this class we will discuss the reaction, the mechanism of the Arndt-Einstert reaction, and the applications of Arndt-Einstert reaction. So thank you very much.